Hi everyone, I'm Sin from Art Science Museum in Singapore. Thank you for making time to join us in Hope from Chaos Conversations, a series of talks accompanying the exhibition Hope from Chaos Pandemic Reflections. Hope from Chaos marks the second anniversary of the arrival of COVID-19 virus into Singapore. The exhibition documents the pandemic's impact on the world by examining the art and science of epidemics. Hope from Chaos also launches the Season of Mental Wellbeing at Art Science Museum, which focuses on mental health and well-being during this tumultuous time. The introductory chapter by the Smithsonian Institution contextualizes the coronavirus pandemic and offers a framework for understanding the connectedness of human, animal, and environmental health. The exhibition continues with an intimate look into the stories of artists Heman Chong, Tao Fei, Luke Jerem, Lonzuzo Zekwa, Pierre Lariche, Iveta Sun Yong Kang, and Ern Vivian Lee, who share deeply personal insights into their lives and work as they navigated through COVID-19. Hope from Chaos also showcases prototypes developed by material scientists from Nanyang Technological University, Singapore, which aim to make an impact towards the fight against the spread of COVID-19. It's our privilege to be joined by Professor Lam Yeng Ming, Chair of the School of Materials Science and Engineering at NTU Singapore. We're going to be in conversation with Prof. Lam to talk about scientific innovation that's driven by the pandemic work of the NTU scientists, and also sustainability-driven innovation in material science that draws on her research. Hi, Prof. Lam. It's a real pleasure having you with us today.
Hello, everyone. The pleasure is definitely mine to be here.
First of all, Prof. Lam, as an introduction to material science as a field and a sort of gentle ease into today's topic, how might you explain the work of material scientists to non-specialists, like me, for instance?
This is a very interesting question. Perhaps I can say that we study and design materials that is used everywhere. So, from materials such as the lightweight metal alloy, heat resistance metal alloy that's used in aeroplanes, space shuttle, to the liposomes, nanoparticles that's used for delivering RNA as the vaccine for SARS-CoV-2 from Moderna. So we do a whole range of material from the very hard material to the very soft materials. We also develop new materials for things like solar energy harvesting, so solar cells as per se, and also high power batteries, which is meant for electric vehicles. We also look into or develop materials that's used for making stents that's actually used to treat coronary heart disease. So basically, we deal with anything that has to do with study, design, and make materials for practical applications, especially applications that's actually useful to mankind. This is actually what material scientists do most of the time.
I'd like to just get to the heart of today's conversation, Prof. Lam. Mask wearing has been one of the key interventions and comprehensive strategies implemented to control the spread of COVID-19 virus. So we'd like to talk to you about the reusable Nanotech Mask that's displayed at Hope from Chaos exhibition for the first time to the public. This mask has been developed by the NTU team of material scientists comprising yourself, Associate Professor Liu Zheng, Dr. Teddy Salim, and Dr. Rui Goncalves. Would you tell us more about this reusable nanotech mask and also share perhaps the impetus behind this project?
Yeah, sure. Actually, this nanotech mask actually consists of two components. I mean, there are two innovations in this nanotech mask. Essentially, is the filter material that can actually filter out 99.9% of bacteria, viruses, and particulate matter. And this is actually coupled together with the antimicrobial coating that can kill bacteria on contact, bacteria or viruses on contact. So essentially, as I said before, there are two innovations here. Is the filter material, which is made of a dielectric material that can convey electrostatic charges. So this will improve the filtration efficiency, even though it's very thin. So the breathability is excellent. And then the coating itself actually consists of a copper-based nanoparticles. And then when bacteria comes into contact with these nanoparticles, essentially the reactive oxygen species generated from these copper nanoparticles will actually destroy and kill the bacteria. So this antimicrobial coating can kill bacteria in less than a minute and is effective for many, many days. Actually, the only reason why the many, many days that ends at the 6 days is because we only tested up to 6 days. It could go beyond. And the reason why we actually wanted to do something like that is when the pandemic first started, we asked ourselves as material scientists, what can we do to help to protect the people? Actually, especially the vulnerable people. So the old people, the sick people, and the young ones, actually practically everybody, and then ourselves as well, our students as well. So we know that the principal mode of transmission, as you said, actually is infected by exposure to respiratory fluids. So any aerosol particulates can actually spread these viruses. So mask is indeed one way to protect everyone. And then we realized that there's also many options for masks and promises. Then the mask promises all sorts of protections for the people. So we don't think that in some cases, of course, it could be true. In some cases, it could have less basis for saying so. So we want to actually design something which is highly affordable. Actually, some of these masks that we see on the market can also be very expensive. So essentially,
Mm.
the poorer folks will not have accessibility to these masks. So we wanted something which is highly affordable and still very effective in protecting people. And that is the reason why we came up with this mask. So for a mask to be effective, you and I and children and old people and everyone has to be willing to wear it. I mean, that is the main criteria. They have to feel comfortable wearing it. So the breathability is very important. At the same time, it should not be at the cost of the filtration efficiency. And that's the reason why we impart some functionality to reduce the thickness and then still improve the filtration efficiency. And young children and actually old people and everyone actually, we unconsciously touches the mask as we wear it. I mean, we adjust the mask, we do all sorts of things. And if the viruses actually stays on the mask and we touches it, essentially we are transmitting forward these viruses, which is also very it's not good essentially. So that's the reason why we designed to have this antimicrobial coating, which is very effective in killing the viruses. So even if the
Mm.
child forget it and have to adjust their mask, it doesn't transmit on to the next kid or to any other people who's around them. Yeah, that's the reason why we decided to go in this direction.
I was also wondering if there had been any sort of challenges or rewards as you and the team were developing the prototype, or whether there had been anything quite unexpected that actually rerouted its development.
Okay. Actually, the challenge is more, during the lockdown period, it's more the accessing the facility. Essentially, we are scientists. We need to go into the lab. We need to do the experiments. We need to find out what works, what doesn't work. So the accessing of the facility was an issue at the start. But luckily, Singapore and NTU actually recognizes the importance of science during this pandemic. So they allow researchers that is involved in this work to continue to do the work, although they are very isolated in the lab doing their own work because there's no other partners around because everyone else are not allowed to come in. So, but then this allow us to carry on developing this nanotech mask, and it gives us the chance to actually work out something which is very effective. And the unexpected part is more like a pleasant surprise part is actually we understand materials, how materials work. We understand what forms is required to be effective, what size is required to be effective. But we were still taken aback by how effective the mask is in killing viruses in a very short time. So that was a actually pleasant surprise rather than some unexpected happenings that rerouted the
Mm.
experiment.
Mm. I'm also wondering in terms of product commercialization, what are the next steps for this project? And also, are there kind of plans to take the research further by applying it to other kinds of viral infections, for instance?
Mm. Actually, it's a very good question. Actually, we realized that actually mask is actually just one step, just the initial step for these development. So we are now implementing these coatings on other surfaces. So this can be used on coating for high touch surfaces, which is used in the hospitals, in the care homes, in schools, in daycare centers where we have vulnerable people. And in fact, actually, it shouldn't stop here. I mean, of course, it's unfortunate that we have COVID-19, this pandemic, but then beyond that, I mean, if there are other infections that hits the world, we should be able to protect our people a lot better. I think with this coating, with these filters, I think a combination, it actually helps. We will help in other infections that actually arises in the future. We certainly hope that there is none, but we have to be prepared.
Um, So on a related note, but a slightly broader questions, slightly broader question: are other kind of current are other current strategies in nanotechnology that could also be repurposed to act against the COVID-19 pandemic? And how is NTU involved in this area of work?
Uh, Again, I think there are a lot of materials-based technology that is actually very useful in this pandemic. Of course, I'm not saying that there are other sciences that are not useful. Other sciences are also very useful. So another example of this is actually the nanotechnology that's again developed by NTU is the breath analyzer called Tracy. So they also make use of actually nanoparticles for sensing. So for sensing the virus. So this is largely deployed in the airport. So that's why in common, I mean, you see in the news report, but you don't see it very much in the public. But they are highly deployed in this area where high number or high amount of testing is required. So this is again another example of using nanotechnology as a form of sensing to again to warn people or to basically give an indication of whether if there's an infection arises from this virus.
Material scientists, they play such a crucial role in how resources can be utilized to their fullest potential. And there seems to be an increasing interest and emphasis as well on sustainability in the context of material science. Prof. Lam, I understand a big part of your research focuses on the design of functional nanostructured materials for sustainable futures. Could we get your thoughts on how conversations surrounding sustainability within nanotechnology and material science have been evolving perhaps for the last couple of years, and also what you think could be an exciting development in this area?
Mm. Yes, yes. Actually, I'm very excited about sustainability research involving materials. I mean, there's a lot of things that we can do here. So in the past, when we think about sustainability, we consider things only like recycling materials and stuff like that. But now we are not just talking about recycling. Recycling is not as exciting because what we want is actually upcycling. So materials waste, plastic waste, turning into high quality graphene material for catalysis or other applications. So that kind of elevation of materials value during the recycling process is something that we are very keen to do and very much in pursuit of now. And also circularity in design. So in the past, we don't think about the materials that we use in all sorts of applications. But now, even at the start of the life cycle of a material, we start thinking about what happened at the end life of the cycle of the material. So basically, we are thinking of materials as a circular economy. So it actually goes back to being effective. So we are also looking at other waste stream, things like food, agriculture waste stream, into turning them into useful products. So some examples are research which is done by one of my colleagues in MSc. It's actually we use food waste as a means to recycle batteries. You know, to recycle batteries, essentially you need to use a large amount of very destructive, very toxic solvents. But now you do not need to do that. You can actually use food waste as a means to recycle these batteries, which is exciting move forward. And also to use agriculture waste as a growth media. I mean, we are talking about food sustainability. If talking about food sustainability, we also have to look at what happened to the waste stream that's generated in these agriculture products. So all these things are coming into mind. So my team also we make use of cellulose from plants which is actually again could be a waste stream from the growth of the maybe fruit or some other plant system that we use as food. So we can now use these cellulose from plants to actually make controlled delivery nanogel for nutrients and pesticides delivery. So controlled delivery so that we can reduce the amount of pesticides used in some of these growing contexts. So of course, we also talk about things like energy sustainability. Energy sustainability is a huge concept, thinking that we have to save energy or we have to effectively use our resources. So things like materials which can help with building energy conservation. So coatings, good windows that can actually even harvest energy because we have transparent solar cells which can now efficiently harvest energy. So things like that are all concept that we are now putting into place. And there are a lot of excitement in where we can put all these potential technologies. Yes.
I wanted to take the opportunity to ask you about your personal journey, Prof. Lam. What has been your favorite part of being in this field or science in general? Or would you be able to share a turning point or defining moment in your work?
Yeah, actually, what is the exciting point? Okay, so I think the most enjoyable part of the whole journey, for me personally,
Mm,
is actually working with many brilliant minds. I mean, those in my team, and the faculty from material science from the school, and other schools, of course, in the university, and also the local and international collaborators. I think this is the most interesting part of being a scientist. Scientist is never, I mean, it is no longer like working a isolated individual in the lab and not communicating with the world. In fact, the way to make an impact is actually work together. And then there are different things that people bring into the solutions, which actually bring up the value of whatever development that we do, which is actually what we would like to. And then the other part that I think is very exciting, which I enjoy as a material scientist, is the understanding of the material structures and, of course, the property relationship of materials, so that we can go on and design more functionality into materials and in turn apply it to real case, real world problems. I think this is a very exciting field because you see the problem, you think about what solutions that you have, you talk to the right group of people, you bring people together, and then you develop the products that's actually useful. I think this is the exciting part of being a material scientist. As for the turning point, I'm not sure what exactly is a turning point, but I think the point which I'm very convinced to be a scientist is actually when I did my PhD in Cambridge. I actually started my life as a development engineer in Texas Instruments. So I actually started my life as an engineer. I totally enjoy it. It's very fun. But I realized that actually my knowledge is limited. So I went on to do a PhD in Cambridge. And during my time in Cambridge, it was very fortunate for me. I get to talk to interact with a lot of very brilliant scientists. And it's actually an eye-opening experience. It makes me actually very determined to pursue material science because of the possibility. And
mm,
actually, the turning point in research is more. I don't think there's a turning point in research. I think it's more like a journey of discovery and innovation, and to be able to discover and innovate and come out with creative solutions to solve problems is actually the beauty of a career in science. I always love to tell that to my students as well. I think it's that really the excitement in science is the ability to discover and innovate along the way.
I guess your response segues very nicely into my next question. For young people and perhaps women as well who are considering a career in material science and engineering, what's your advice for them?
Yeah, actually, I get asked a lot this. I
I'm
think,
sure.
yeah, I think the most important, but actually the journey, I think journey in any career is not easy. I mean, there's always ups and downs. I think one should always bear in mind why we are excited about material science, about research, or about science in general. So we need to always go back and think why we chose this in the first place. What gets us excited? Of course, the ability to come up with solutions that can improve life. You could always should remind ourselves this is what we wanted to do. And although the journey, like what I said, can be challenging, we can find collaborators, we can find people who actually rallied around us and that help us out, which is our collaborators, our friends who are scientists as well, and to overcome some of these challenges. Of course, it's actually very important to have a very good support system. So the family and friends, of course, and
Mm,
definitely we also need to practice some self-care. So we need to know when we have to slow down and perhaps to think about other things. That is very important in life as well. But I think the support system is very important, and knowing when to talk to people, when to ask for help is also very important.
my last question, Prof. Lam, this loops back nicely to the Aspect and Hope from Chaos exhibition that explores rituals of care during the pandemic. Apart from doing research, how do you practice self-care during this period? What has been a specific source of comfort for you?
Okay. Yes. Actually, I have to say my family helps a lot. I have to be very disciplined. Actually, during this pandemic, there's a lot of meetings that's online, so the
Mm,
timing for the meetings can last beyond working hours. So it's very tempting to blur this work
mm,
and leisure time. So, but luckily, I have a very young boy. My boy is only like 7 years old, who has lots of energy. So we love to go cycling and walking. So he sort of give me a time when I have to stop and I have to spend some time. But of course, I'll pick it up again when he's resting and stuff like that. So we spend a lot of time doing things that we like going outdoors, cycling, walking.
Mm.
Although we can't do, I mean, we also love skiing and hiking, but now we can't do. So, and also for personal time, I also love to paint. So it helps me a lot also. So actually having something that is a bit distant from what we are doing, it helps a lot, I think.
Wonderful. Thanks for your time and generous sharing today, Prof. Lam. Also, thank you to all of you who have been with us across the duration of this talk as well. The upcoming online talks in the series will feature artists Luke Jerem and Tao Fei. Luke Jerem first caught the world's attention with his mesmerizing glass sculptures of bacteria and viruses, which now form a series of works he calls glass microbiology. His coronavirus glass sculptures have been used to help visualize and communicate the signs of the pandemic. We will be in dialogue with Luke to talk about his coronavirus works, which are presented for the first time in Asia in Hope from Chaos exhibition. And the concluding talk by Beijing-based artist Tao Fei looks at her work Out of Instability, created while she was in lockdown with the family in Singapore. While reflecting on the limitations the pandemic has imposed on her day-to-day life, we will also be discussing with Tao Fei the role of art, creativity, and making as one of healing, soothing, and promoting optimism in times of difficulties. We hope you get a chance to visit Hope from Chaos Pandemic Reflections, which runs until the 3rd of July, and join us in this accompanying programs if you're able to, including the exhibition's guided tours, which are led by our wonderful education team. You can, of course, get more details and stay up to date with everything that's happening at the museum via our website, Facebook page, and YouTube channel. Once again, Prof. Lam, thank you so much. On behalf of the museum, we wish you and the colleagues at NTU our very best for all the ongoing work as well as your forthcoming projects. Please keep very well.
Thank you very much.